Hello friends, this is a 2-mark question on DBMS on topic functional dependency and normalization. In the question, we are given a relation R with 6 attributes and asked what is the minimal number of tables formed after decomposing the above dependencies into 3NF. In order to answer this question, let us first determine the normal form of this relation. For this, let us calculate the candidate keys for this relation. As can be seen from the set of functional dependencies, attribute A and B does not occur on the right side of the functional dependencies. So all candidate keys must contain AB. From attribute A and B, we can derive all other attributes in the relation. So the candidate key for this relation would be AB. And this implies that the relation R is in 1NF because attributes C, F, and E are partially dependent on the primary key, which is AB. So, it violates the second normal form. Now, let us decompose this relation into 3NF. For this, we need to calculate the minimal cover or canonical cover of this given set of functional dependencies. Minimal cover is nothing but the subset of original functional dependencies which is equivalent to the original set of functional dependencies without any redundant attributes or functional dependencies. For the above set of functional dependencies, the minimal cover would be A's closure as A, C, D, F, while B's closure as B, C. We remove the functional dependency C implies D from the set of functional dependencies because it can be inferred from the functional dependency A implies FC using transitivity. Now, in order to decompose the relation R into 3NF, which is dependency preserving and lossless, we need to create one relation for each functional dependency in the minimal cover. So, for this, we will need two relations which are as follows. R1 consists of attribute A, C, D and F, while R2 consists of attributes B, E. Here R1 corresponds to the first functional dependency in minimal cover, whereas R2 corresponds to the second one. Since the relation R has key as AB and this key does not occur in any of these relation R1 and R2, we need to add a trivial relation R3 with attributes A and B. So now the original relation R is decomposed into three relation R1, R2 and R3, out of which R1 has the functional dependency from C to D. Hence, this is in 2NF because the key of relation R1 is A and attribute D is transitively dependent on attribute A by functional dependency C implies D. So it violates the definition of 3NF while the other two relations are in 3NF. So we further need to decompose the relation R1 into 3NF. So if we decompose the relation R1 into two relations R11 which has three attributes A, C and F and R12 which has attributes C and D, both of these would be in 3NF. So in total we have 1, 2, 3 and 4 relations. That means the number of minimum tables after decomposing the original relation R into 3NF would be 4. So the correct answer to this question would be 4. Thank you.